Hello. So hope you had a nice weekend. Homework 3 is due this Friday. I'm seeing a lot of people are submitting and doing a really great job with it. I'm expecting that there will be a lot of questions on that. I fell a little bit behind last week. I was hoping to cover more things, but due to canceling class and then also the weekend, the long weekend, I'm feeling there's a little bit of a time crunch here, but hopefully you all will be successful in completing homework 3 by Friday still. We're going to talk a little bit more about C++ today, but I also want to talk about your homework 4, which I have just posted. So section this week, I believe all of you have had section at this point, unless you were on Monday. So the purpose of section this week is to meet all of your group mates for your final project, and I expect that you all should be working on setting up your repositories and setting up the continuous integration and everything that is needed. That is all a part of homework 4. Cool. So I wanted to mention one thing, though. So if you had a Monday section, then you have not met your team yet. What you all can do is you can go onto Canvas, and you can see everyone in your group. If you go into the People tab on Canvas and then click on Final Project Groups at the top, then you should just be able to see all of the groups and see how all the groups are created, and you should be able to see who is in your group. And what I highly recommend doing is trying to email all of your group mates this week, maybe even today, and try to schedule a time to meet with them remotely so that you can finish homework 4 as soon as possible. Because the sooner you finish homework 4, the sooner you can start your final project. And your final project has already been posted on Canvas, so I highly recommend reading through that. We're going to talk about the final project either this week or next week. Kind of the most important thing, though, is just setting up GitHub and getting everything installed. And then starting next week, we're going to be talking way more about the final project and what is required to build an emulator in C++, a high-performant emulator that can run the games that I provided. So please try to make a meeting with your group mates this week if you were on Monday. Cool. Did anyone happen to pull up the People tab, and can everyone see your group? Cool. Okay. Yeah. So getting thumbs up. If you cannot see yourself in a group, then something weird happened. Please let me know as soon as possible. I'm also getting a few requests that people want to switch sections. Okay, that's fine. I guess it would have been nicer if we had found out about that sooner before we already assigned all of the groups. If you need to switch sections, like if something terrible happened where you realized that you needed to sign up for a course because you weren't going to be able to graduate on time without this course, but it conflicts with the section that you're in, then I understand accidents happen, but please let Gurpreet, the TA Gurpreet, know as soon as possible. Do not let me know. All I will do, if I have time, if I happen to be checking my email, checking Piazza at that time, I will just send the message over to Gurpreet, and he will figure it out. So please do not message me if you want to change your section. Message Gurpreet. But ideally, please stay in the section that you're in, because it causes him a lot of headache, because he'll need to email people who have already made their groups. He's like, hey, so sorry, but I know you already made your GitHub repo, but is it okay if you swap out for this new person who had to switch their section? It's really inconvenient for us, so try to stay in your same section. If you have a big conflict, though, then that's fine. Question? Can we create our own group? The question is, can you create your own groups? We have already created the groups for you, so you will need to stick with the group that you are in. If you have a problem with your group, though, then let Gurpreet know as soon as possible. But we have assigned you a group. Okay. Cool. But it's okay, though, if you are not familiar with everyone who's in your group. I think that this will be a great opportunity to meet some new people. You can also collaborate with your friends who are in a different group, because now you can ask them for their debugging strategies, because every person's game emulator will be slightly different. Every single person was given different ROM files and different documentation. Every group has a slightly different permutation of the different possibilities of what the emulator could be. And the purpose of that is so you can more easily collaborate with other teams, and now you don't feel like you were going to be, whatever. It would be harder to copy off of other teams' work because their emulator won't work for your code, and whatever, their code won't work for your emulator. Cool, okay, good. We'll talk more about the final project starting next week. But first, I wanted to give you a couple examples of some more standard library C++ things. Hopefully we have seen this all before. Cool, so the first thing that I want to show you is, so I have this example project right here. Okay, so here in main, so I have a list of names, and I have in them I have just a number that I have put. So this is a pair. It's a string and an integer. So we have Ethan 2, Abby 3, Frank 4, whatever. So we have all these numbers and names. But then if we want to sort this array, because there is not like a built-in comparison method for pairs, what we will need to do is we will need to specify a compare function. So here, like, it's kind of interesting. Maybe you've seen this before. But what you can actually do, and this goes for basically every single language, is you can actually pass in functions as function parameters elsewhere. So here I have this function sort, which is given to us by std algorithm. And what I'm doing is I'm passing in this compare method right here. And this compare method takes in a pair with a string and an integer. And it takes in, values A and B. And so what we can do then is we can, if we want, so we just return any sort of Boolean. And if we wanted to maybe sort this array now by maybe the number, then what we could do is we could write a customized sorting, like a customized comparison function. And so for this, we would probably do something like a.second is like less than b.second. Okay, so let me run this and see now what happens. Okay, good. Okay, so G++ sort. Come on. Oh, it froze. Okay, cool. And then main and. Okay, so now I've just run this, and now we can see this value. So yeah, so it looks like it does in fact print it in order of the numbers. You can see that Mike was moved forward. There we go. So cool. We have successfully created our own comparison method. Good. Any questions on this? Okay. Yeah, question? This? 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 Yes. Okay. Oh, yeah. Thank you. Yeah, good. Oh, good. Yeah. So the question is, what does this less than and greater than, what are these symbols? These symbols are specifying what types are being assigned to this pair. So we're saying that this is a pair that has a string and that has an int. Meaning, so a pair meaning it's kind of like it's like a tuple, it's like an array, where the first element in the array is a string, and then the second element in the array is an int. Yes, this is a pair. Yeah, another question. Yeah, I will absolutely get to that in a second. Any other questions on this? Okay, I'm going to get back to the and symbol, but okay. Wait, really quick. Turn to your partner. What if we now wanted to modify this to where if the numbers are the same, so if we have, for example, Frank and Steve are both 4, then how could I modify the code so that now it sorts it, if there are ties, it now sorts it alphabetically? Okay, turn the person next to you. How do we modify this comparison function to now fall back as sorting alphabetically? Okay, begin. Okay. Anyone? Any thoughts? Okay. Yes? I don't know if we can do that. So the thing was, the thing that was said was return A is less than B. I'm not sure. I think we might have to actually override this like comparison. I don't think we can just do that. I don't think that there is a. Actually maybe. Anyways, okay, we'll come back to that. Let's pretend like we can't do that. Okay, what do we do? Any other ideas? No? Yeah. What was that? Compare strings. Yeah. So what should we write here? So, okay, hold on. So let's say that the numbers are equal to each other. Will this return true or false? This will return false. Okay. So that probably means that, like, if they're equal to each other, that means that there's not enough information in this. So then if we wanted to add either like an and or an or after this to check, because what will happen next will probably be something like A dot first is less than B dot first. Sorry. Okay. Right. It'll be something like this. But the question now is, what operation do we put in here? Well, we know that if they're the same number, and this is, if they're the same number, this will be 0. So that means that if this was an and, then we probably wouldn't even look at this. So we know it can't be and, because if it was an and, then we would say like this is 0, so therefore we don't care about what else is happening here. So instead, it should probably be or. Okay, good, bad. Does that kind of make sense? Okay, let's run it. Let's see what happens. Okay, cool. That may it looks like nothing really changed, but now if we go in to change some more. If we change these all to now have the value 4 or something, then we can see if it worked. There we go, cool. So it looks like, in fact, it does sort it now alphabetically if all the numbers are the same. So this is the comparison method for, that we have decided works best for this use case. Okay. Instead, maybe you are writing a file analyzer class where you need to sort a list of characters now by their usage, right? Has anyone needed to do this past week? Yeah? Okay, a couple people have gotten to that part of the homework. It may happen where you need to sort something, sort a list of pairs or something by some kind of specific use case. Sorting a list of characters by their usage count. That would be a total reasonable use case of overriding the comparison method and then passing it into this sort method. Cool. Would anyone like me to say this again? Getting like half the room is like confused looks. Feeling okay? Okay, cool. You're all experts. Good. So now I wanted to show you one more kind of cool thing about vectors. Vectors, there's so many great features that they have, not just sorting. Another thing that std algorithm provides you is this std find method. So here I am creating a vector, vector, and it looks like it is storing a bunch of integers. And I'm going to get rid of this example because I wasn't doing this anymore. Okay, sorry. Cool. Okay, so here I am pushing back 10 elements, and they were all random numbers between 0 and 100. And then what I'm trying to do is I'm trying to find the number 500. And let me actually get that back. Okay, cool. Good. Okay, so let's now run this example. Okay, good. So here it says found 500 at position 0. And I would say that that can make sense because first we're pushing back the element 500, then we go and push a bunch of other elements, and yeah, and there we go. If we wanted, we could search for other elements. We could also, yeah, scramble it, and then we could search for it. Cool. So this is the find method. There are a lot of other really great methods here. I just want to show you this example in case you haven't seen this. Yeah, question? Yeah, sure. Sure. Right. Yeah. Thank you. Yeah, no, good point. I totally agree with that. A bug has been uncovered. So if we look at this, we will notice that even if they are not equal to each other, then we will still be comparing this. So instead, what we should probably have is something maybe it's like, oh, like if they're equal to each other and this. And then we have like another thing that is like an or on this. Is that right? Or maybe and? Yeah, or. Maybe something like that instead. Yeah, so we're now kind of, there's a more separation where the most important thing that we're checking is this, if the number is less than. And then after that we check, well, if it's equal, then now we go and move on to the later thing. Move on to the name, alphabetical. Yeah, thank you. Good. Cool, so good. Yes, I want to also spend a little bit more time on something called iterators. So you're probably used to writing for loops where you have maybe like int I equals 0, and then you operate through the for loop, and you plug in element I, and you get the first element, second element, third element. You're dealing with integers. And so let me show you kind of what that would look like, right? So if we were to print this out, I'll comment this out for now. Okay, so if we now wanted to print out every element in this vector, then what we would probably do is for like int I equals 0, I is less than v dot size, I plus plus, and then we could do cout and we could say v dot at I. And so what this would give us is it would just print out every element in the array. And we can run this, and yeah, we can see it's not very exciting, just prints out all of the elements. Cool, okay. But a potential issue with this, I guess, is it's not a very universal style of writing code. Like if we wanted to write, if we were writing our own find method, and we wanted this find method to now not just work for vectors, but maybe work for other data types, maybe like a dictionary or something, or some sort of other, like maybe like a linked list or something, maybe something that is not indexed by like just sequential numbers, then what we can do is we can use something called an iterator. So iterators are kind of like this idea of using like an integer to access into a vector, but instead we can use this, it's almost like a pointer, but it has like a next method where we can do plus plus and it gets us like the next value in this container. And so for at least for vectors, it looks very similarly. And so the way we do it is we say auto it. So instead of I, usually you say like it for iterator, and then you say it's equal to v.begin. And v.begin it's like a pointer that points to the first element in our vector, and then we keep sequentially increasing the iterator until eventually it equals v dot end. And v dot end is saying like we've reached the end of our vector. And so this style of writing for loops, you'll often see it in C++. This is an iterator, and what's nice is that this will work across all different container types. So for example, we're going to talk about dictionaries in just a second. Cool, so what we can do is we can print out this, and you can see, so we are dereferencing this iterator here, kind of similar to as if it was a pointer. So yeah, you can basically just treat it as if it's a pointer. So let's now print this out. And there we go. So now we can see just all of the elements printed out right here. Cool. Okay, and then the last kind of main way of indexing into an array or sequentially going through an array is by using a range-based for loop, or also called a for each loop. So here, so auto. What is auto? Anyone seen auto before? It's cool. Yeah, exactly. So auto will infer the type of whatever you are creating. So here I am creating an iterator, and we can tell it's an iterator because v.begin, if I hover over it, you can actually see the type up there. It is, you can see an iterator. It is it's kind of a messy sort of type. And so that's why, especially for iterators, that's why it's generally always best to use the term auto. And for here, we're also using auto. If we wanted, we could change this out for int. Cool. And good. Cool. So and then here I'm just sorting again, and so this is kind of the main thing that I wanted to show you. Cool. Feeling good? Okay. Good. I'm kind of running through these examples. We're going to move on to the next thing. So, okay. In Python, anyone used Python before? Okay, good. What is a dictionary in Python? Can someone give me an explanation of this? Actually, before that, can you explain to the person next to you what a dictionary is in Python? Maybe they've never heard of it. Okay, go. Take 1 minute, explain to them what a Python dictionary is. Okay, Python dictionary. What is a Python dictionary? Okay, yes, in the yellow.
Essentially, an unordered list that instead of consisting of the index value uses keywords for the index instead.
Sure. Yeah. So to reiterate, so a Python dictionary, it's a really great data type that we've probably all seen before. It is basically just a list. It's like an unordered list where you can index the elements with not necessarily a number. You can if you want, but you can index it with anything. So you can use maybe like a string to index this, or you can use some other data type to index the number. This would be great, like if we wanted to maybe look up like student IDs from emails. So you could have a big dictionary of, you would have as the key, you would store the email, and then when you pass in the email, maybe you get back an integer, kind of backwards from the usual way that we think about arrays, where you pass in an integer and then you get back the value at that index. Yes, question? Sure, okay. I guess Python dictionaries are ordered. So C++ has a has an implementation of this as well, and it is called a map, or an unordered map. So here is an example of this in action. So here we have a string to integer map. So you can see that here we are taking in the Apple string, and then we are assigning this value of 10 to this location in memory. And then here we're taking in this banana object and then putting it at 20. And then here, I guess we are fetching out this value at Apple. So if I now print this out, so if I do std cout and print this value, okay, then turn to the person next to you. What is this going to say? Come on. Okay, and it says 10. Is this what we were expecting? Good, cool. Yeah, perfect. Cool, so this is an unordered map. They're really incredible. They're extremely fast. Has anyone taken a data structures class before? Okay, fantastic. Okay, great. So a map is actually stored, I believe, as a tree. Okay, so when you store something in a map, what will happen is there's this big tree structure, and it will navigate the tree, and it'll figure out exactly which location to put in. It might be a red-black tree, if you're familiar with the red-black tree. So that is how the map object is used. There is also a type of map called an unordered map. And unordered maps are used extremely similarly. Where here, so we're still, as we create this map object, you can see, so it first takes in a string as the key, but the value that it stores is an integer. So it looks like very similar, and if we rerun this, then now it should continue working. There we go, 10. However, since it is unordered, it is slightly faster in some ways. Does anyone know what data structure this would be implemented with? Anyone? Okay, so this is implemented using a hash table. Anyone heard of hash tables? Oh, anyone not heard of hash tables? Okay, I'm missing half the class right now. Wait, okay, who has heard of a hash table before? Okay, good. Thank you. Okay, it helps to understand where everyone's at. Okay, cool. So unordered map. So this is implemented as a hash table. So built into C++, there is a hash function that will map Apple to a hash. And what is a hash? What does it mean to map a string to something else? What do we store it as something else? What is a hash? Yeah. What data type do we store a hash in? What was that? It's an integer. Yeah. So the idea with a hash function is that you will take some sort of input, so you could pass whatever you want. In fact, you could even put in a pair here. You could put in, as your key, you could put in a pair, and then you could write your own hash function that converts it into an integer, and then that integer is actually used to index into an array. So that is how a hash table works, is you just have a big array with a bunch of indices, and then you will use a hash function to figure out exactly what index the data will be stored in. Okay, cool. So that was a quick reminder of what a hash table is. Feel free to come up more and ask more. What now is the time complexity of inserting an element into a hash table? Okay, anyone? Yeah? It is constant time, yeah. So in order to insert data it is constant time, so it does not depend on how much data is already stored in the array. Okay, what about deleting an element from a hash table? How much time will that take? Okay, yeah. Also constant. Okay, what if we wanted to find an element out of a hash table? How long will that take? Also constant, yeah. So hash tables are really great because they are extremely fast. One of the big downsides of hash tables, though, is that they take a lot of memory because oftentimes you have to create very large arrays in order to leave room for all the possible mappings of a object to a specific bucket in your hash table. Yeah. Anyways, okay, cool. Unordered maps. Anyone use an unordered map in their file analyzer implementation? Okay, good, cool. We got a few people. Yeah, I'll just quickly show you this. I did it in my implementation. So here's my solution. So we have the file analyzer text class. You can see I am including unordered map. And then down here, for my letter count, you can see that I am converting from a character into a count right here. And maybe this is a bit overkill because if we have a character, there's only 256 values. So I probably could have just made an array that was 256 long, but instead I chose to use an unordered map just because I thought that would kind of look cleaner in the implementation. Cool. Anyone else do this? Yeah? Yeah. Cool. Okay. Cool. Good. Great. So, oh yeah, question. If you pass the test, then you're fine. Yeah. The question was, do you need to use 64 here for the letter count? Yeah, for the purposes of homework 3, your final grade on that assignment is actually just whether you pass all of the tests. So we're not going to be checking any additional tests from what you see on your GradeScope score. Yeah, cool. Good. So, yes, there is another thing that I wanted to chat about. So, yeah. Okay. So in your file analyzer assignment, there is a requirement that you need to implement a parentheses matching checker, or parentheses checker. And this is an extremely common interview question. I personally have received an interview question on parentheses matching twice. And I'm not even a software engineer. I design hardware. I design computer chips. But from the limited software engineering, software engineering interviews that I've had, I have, on 2 separate occasions, had a parentheses matching question asked to me in a technical interview. So therefore, I thought it would be fantastic practice to give all of you this question. So the question is, so if you have maybe a text document, so if I have this text document, if I say hello there, and then I put in parentheses, I can say bye, okay? You can see actually VS Code is pretty nice because it actually will highlight automatically for me. It'll highlight if I have a missing parentheses. So VS Code, by default, will let me know if I am messing up my parentheses at all. And and in fact, it will do it for all the different parentheses types you can see. This is great. But, how does it actually know? So what I thought we would do is we just chat about what algorithm we would probably need for this. So, okay, what I want you to do now is turn to the person next to you, turn to your partner, and explain to them what algorithm you would use in order to check, give a Boolean, true or false. It's does this file match all of its parentheses? Okay. Go and explain to your partner how you would implement that algorithm. Okay. So let's discuss possible algorithms. Okay. Oh, yes.
My idea was to have a counter, and every left parentheses it adds one,
Mm-hmm.
right parentheses subtracts one.
Yeah.
If you have 0 at the end, then you know it's fine.
I love that. Yeah, okay. So the algorithm was all you do is just have a counter for each of your 3 parentheses types, and if it finds a left parenthesis, then it will increase the counter, and if it finds a right parenthesis, it will decrease the counter. And now, if you have the same number of left parentheses as you do right parentheses, then that means that at the end, your counter will have the value of 0, and that means that you have a correctly balanced program. Cool. There's a slight edge case that we'll come to in a second. I'm sure a few of you are kind of on the edge about that. But okay, let's just see this in action. So sure, if I have, let's just write out. So these are my 3 counters. Actually, I'll add these as well. Okay, so if we start out and we all have a value of 0, and let's go and do this. Okay, just this very basic example. Let's test this out. So here, we will increase by 1 this bottom square parentheses, right? Okay, and then immediately after that, then we decrement it by 1. So now we're back down to 0. Then down here, we have value of 1, and then we decrement it right after. And then for the curly braces, we increment by 1, and then decrement by 1. So therefore, it does in fact look like this works. Okay. Can anyone give me an example string where they think maybe this won't work? Oh, yeah.
When we start off with a right parentheses,
Uh-huh.
it would start off with a negative counter.
Oh, okay. Sure. Even though maybe the next one, maybe we do something like that. Yeah. So for this case, check this out. So now, okay, clearly this should not be valid. But what we will do is we can say like, yeah, okay, if maybe starting out, we just subtract 1, and then now we're at -1. And then if we increment it back up, then now we're back at 0. So it looks like our algorithm does not properly determine whether these parentheses are balanced. But that's fine, because we could probably just add a little check right here that is like, if this ever goes negative, then that gives us an error. Right? Okay, so let's now test this algorithm really quick. So yeah, I don't know if I do, well, okay, never mind. Okay, cool, okay. Does someone have another edge case string that they would like to give me? Yes, in the back.
So if like the parentheses were intersecting, like say opening like regular parentheses,
Okay,
and then like an opening and then a opening like square parentheses,
opening square.
and then the closing brackets would be outside.
Maybe like this? Okay, let's see. So should this be considered valid? No, this should not be considered valid, but if we test it out, we can see it adds 1, okay, then it adds 1, okay, then it subtracts, okay. So therefore, it looks like it would pass according to our algorithm. Yeah. Okay, so there's something a little fancy here. This is why it's a very common interview question, is because there are a lot of kind of potential ideas that you may have in order to fix this, but there's really only one major solution. Okay, does anyone know the kind of the well-established, like the way that most implementations deal with the matching parentheses problem? What is the data structure that is used in order to store this? Yeah, a stack. Yeah, so there's a data structure called a stack where we will push an item onto the stack. It's basically just an array where you push items back to the stack. And then when you want to remove elements, you can only remove elements off of the back. So you can never access the front. You can think of this as like a stack of trays on a table. Like you can't, or a stack of books. Like you can really only grab the thing off the top. You can't like really grab something off the bottom. So that is the analogy for the stack. So now let's change this up a little bit, where maybe now what we do instead is we push all of these elements onto a stack as we read them. So first, we look at this round parenthesis, okay? Actually, first, let's do a working example. So let's do this, this, this. Okay. So yeah, maybe what we will have is we'll have a stack. So first, we will add on this round parenthesis, and then we notice that the round parenthesis has a match right here. It has this match, so therefore we can remove this opening parenthesis because we found this match. And then next we can push onto the stack another curly brace, and then we find that we have a match. So then we delete it. Okay. Then next we have a square bracket right here, and then here we have a match. So then we delete it. Okay. Maybe a better example would be if we have maybe like nested kind of like this. So let's test this out. So here, if we're pushing things onto the stack, so we push on first the square parenthesis, then we push on the curly brace, then we push on the square brace, then we see that there is a square brace here, so then we delete this. Then we see there is a curly brace here, so we delete this. Then we see there is a round brace here, so we delete this. And only if the stack is perfectly empty at the end and all of the matches were as expected, in that case, then we have a matching set of parentheses. Okay. Let's go through a bigger example. So yeah, let's say maybe here we have a set of intersecting parentheses like this. Okay, so we have this feature. So first we push on the curly brace onto the stack. Then we push on the, parentheses, then curly brace, then square brace. Then we push on another round parenthesis. And then after that, we have the square bracket. And with this square bracket, we see that there is an error. Why is it an error? It doesn't match the top of the stack. What does the top of the stack expect there to be? What is expected from the top of the stack? Yeah, it expects a closing parenthesis. So if we go in and make it be a closing parenthesis, there we go. So that would then remove this, and then now we have this square bracket, and so we remove this, then we have round parenthesis. Oh, is this an issue? Yes, because what was it expecting? It was expecting a closing curly brace, but instead it received this parenthesis. Yeah. So therefore, this would cause an issue. So I guess we can just remove that, and there we go. We can see VS Code is happy once again, and we can remove this, and then the last parenthesis is this closing one. So there we go. Cool. Good. Yeah. Question. So the question was, how do we deal with quotes? In homework 3, I'm just assuming that you don't have to deal with quotes. But if you did want to deal with quotes, then it would be very similar, where you would just have something that is like, if you have quotes ever, then I guess you would stop looking. I guess it's kind of complicated. It's a little bit more complicated, but yeah, you could think through it, and you could, if you wanted, implement a way of supporting quotations. Yeah, you could also think of the way to support comments like this, like opening and closing comments. Cool. Okay. If we feel like we need more help on this, I'm happy to discuss this further this week. I think this should be hopefully a good enough place for you to start out on. I will also say that C++ actually includes a stack data structure that you can use. And what I would maybe recommend doing is asking ChatGPT to show you how to use a stack. If you want, also, you could look online, like for examples of how to use std stack. I could walk through it, but I feel like it's kind of most useful to just do it and play around with it. But this is the algorithm for balancing parentheses. And I would also recommend maybe going home and like I don't know, maybe your friends can give you like a mock interview and you sit down and try to like crank out an implementation of matching parentheses while someone's like breathing down your neck and you're feeling uncomfortable. Yeah, okay, cool. So that is an important algorithm. I will continue kind of poking around common interview questions that I've seen or that I know other people have seen, just because, yeah, I want you all to be well prepared for your job interviews for whenever you get an internship. Cool. Okay, I'm going to grab some water. We're going to shift to GitHub in a few seconds. So that is all kind of the C++ that I want to talk about. Oh, I will mention, because we are a little bit behind, the quiz this week will actually be held remotely. It will be due Friday, so you'll just have a few days to work on it. It will be covering things last week. It will also be covering some things this week. It will not be held in lecture, although you are still welcome to work on it with a partner remotely. Yeah, more information will be sent out. I'll post information on Canvas about that. So no quiz today. The last 15 minutes of lecture, though, I'm going to talk about GitHub, Git and GitHub, so that ideally you're all prepared for homework 4. Okay. Good. Cool. So, how do I want to start this? Okay. So, back in the day, when people wanted to design software projects, what they would originally do is they would just write a C file, maybe not C, maybe they would write it in assembly or something. They'd write some file, and on it, like way back in the day, the second that they unplugged their computer, the program would go away. But then when files were created, then people were super excited because now they could actually save their files. Like, wow, like save it to a floppy disk or to some like flash storage or something. This was magnificent. But then as software projects started getting bigger and bigger, then now it became more important for a lot of other people to work on software projects at the same time. And it became very apparent that having a bunch of people all working on the same code base at the same time was actually a fairly challenging process, because if someone was working on one feature and someone else was working on another feature, maybe if you now wanted to have both features be included on the same code base, it's actually not super trivial, because like how do you remember, how would you go back and remember exactly which lines of code you edited so that you can copy and paste them all together? And so because of that, there were multiple tools created for versioning, so version control. And the idea of version control is code safety. It's because if you work really hard on fixing a bug, you want to make sure that that bug is permanently fixed. You don't want someone else coming in and maybe they accidentally overwrite that one tiny little line of code that you changed in file like 203 line 7000. If you change that one line of code, it's maybe hard to keep track of that. So therefore, there have been multiple applications created for versioning. One of these applications is called Subversion, if anyone's heard of Subversion. This was kind of the main big one that people used for many years. So maybe some of you have heard of this. But then this man came along called Linus Torvalds. Anyone heard of Linus Torvalds? Okay, cool. Linus Torvalds, of course, is well known to be the creator of Linux. So if you are to know any software engineer by name, he's probably the most important person that you should just know. So Linus Torvalds, you should just keep that in the back of your mind. If anyone ever mentions his name and you say, oh, I don't know who that is, they're going to kind of think like, oh, so like, did you actually study computer science? So yeah, make sure that you know who Linus Torvalds is. He's kind of most important kind of software developer. But as he was writing this operating system, Linux, which uses thousands of files across like hundreds of developers, he needed a much better application for versioning. And so he created another versioning program called Git. And Git is still used today. Git, I think I can't remember what year it was created, but it's been widely used, and it's only kind of become the most dominant thing. There's nothing else that has come close to Git in terms of popularity for version control. And then GitHub came along. It was created by a small team, then bought out by Microsoft, and it's kind of unfortunate too because as Microsoft has become more and more kind of worse company in the public light, and maybe it's not the best idea for me to be promoting GitHub as a good service. There's been talks. I think UC Santa Cruz actually has their own Git hosting platform. Anyways, that's a little side tangent. GitHub, really great platform, but maybe not the best people running it. But it is a hosting service for your Git repositories. So it turns out that actually there are all sorts of projects that are hosted on GitHub. And in fact, you can even look up the Linux repo. Linux is not officially hosted on GitHub, but you can actually find the Linus Torvalds you can find his profile page right here. This is here he is there, and then here is all the source code just for Linux. Anyone compile their own Linux kernel before? Yeah. Okay, we got a couple people. Yeah, I tried doing it recently from my computer. It's kind of anyways. So here's Linux. Another open source project. Dolphin. Anyone heard of Dolphin? Dolphin? Yeah, so Dolphin is a GameCube emulator. And if anyone's heard of the GameCube, this was the main system that I grew up playing. Great project right here. It's all managed on GitHub. And you can see, so if I wanted, I could scroll through every single change that was made in this entire project. You can see there were 43,000 commits for the Dolphin emulator. And I can scroll through all of them, and I can look through exactly and see what lines were changed. I can see this line was changed, whatever. I can see who created it. I can see when it was created. And not only that, but I can also see this little checkbox right here, which denotes whether or not that change broke anything, if there were extra tests that started failing because of this change. And you can see the history of everything. And I use GitHub for everything, for writing all homework assignments, for my research. GitHub, really fantastic. And I would say most software developers nowadays use GitHub for storing all of their Git repositories. So there we go. I wanted to quickly, I'll just spend 4 minutes kind of walking through getting GitHub kind of basically set up. Hopefully you've kind of all seen GitHub in some way already, but I just want to kind of walk through it super quick. So first I created this GitHub repository. So this is called the PR example Winter 25. So this is public, so you can all find this if you wanted. And I have grabbed the link to it right here. And so I've already cloned it. And in fact, I'll show you this. Okay, so this is the command I ran. So I ran git clone. And this is how you fetch the Git repository. And then what I did is I opened this repository in VS Code. And if any of you are using Windows, then I highly recommend only opening VS Code from the terminal. So this is how I open VS Code, is I type in code, and then I put in the directory name of whatever I'm trying to open. So I ran this, and now I have VS Code opened like this. And when you open VS Code with this means, then you can do control backtick, and it will open up the terminal. And you can see it actually is running bash right now, as if it was Windows subsystem for Linux, as if it was in this container. I don't need to worry about specifically opening VS Code inside of this terminal. It is already created for me. Yeah. Okay. Cool. So here I have a bunch of these kind of random starter files. I have whatever CMake lists and README and stuff. The way that I can commit all of these files. So first, let me just do git status. And so here I can see all of the files that I am adding, or that I want to add. So it says use git add to include what will be committed. So here are all the files that I would like to be added to my Git repository. And and the purpose of this is for versioning. Like I want this to be cemented in. Like right now, these are kind of just temporary, like floating changes, but I want them to be cemented in so that I keep track of like when I've made these changes officially. So I'll do git add, and I will type in all of these. Git ignore, cmake lists, readme, and src. Okay, so now I've added all these files. So if I do git status, then we can see that I have currently, I'm about to, I've staged all of these files. And so, and if I wanted, I could go back and be like, actually, no, don't commit that. But I'm ready to commit all of these. So now if I do git commit, and then I can specify a message. So I'll just call this initial commit. Okay, so now I've committed all of this. Now if I do git log, then there we go. We can see that I have officially made a commit. And every commit is just a list of changes as well as a hash that points to that commit. If you think of hash tables, right, it's the exact same thing. So here, it's a hash. So if I ever wanted to go back in time and like remember, like, oh, like what was that change? I can just go back to this hash. This is like the identifier for all of these changes. Cool. Good. And now if we go onto GitHub, so we can see, even though I'm hitting refresh, you can see nothing has happened here. And that's because, so I've committed this to my Git repository. So that's good. So if I actually do ls-a, then we can see that I have this .git folder right here. And notice it doesn't show up over here, but I do have this .git folder. And the .git folder stores a bunch of things related to the Git repository. So this will keep track of all of my changes that I've made. So if I now go and make another change, then you'll see that the Git repository will now grow because it actually stores every single possible iteration of your code base in this .git folder. So this is what makes this a Git repo. But if I now wanted to push this to a hosting surface, such as GitHub, then all I would need to do is I just do git push, and then I say origin main, and this will now push it to GitHub. So if I now hit refresh, then there we go. Now we can see all my files here, and we can see that it was my initial commit, and here are all my files. So there we go. I think I'll post a GitHub getting started tutorial. There's one that I really like out there, just in case you need a little bit more on this. I'm going to show you one more thing, though. Why didn't this? Sorry, just one quick thing. Yeah, good. Okay, so you need to do this for homework 4, so I'm just going to quickly mention it. So notice that we have this green check mark right here. Okay. This green check mark identifies that we are actually running continuous integration on this. So continuous integration is crucial for this course. You will be using continuous integration for your final project as well as homework 4. The idea with continuous integration is every time you make a change to your repository, GitHub so graciously is actually offers a free server for you to run some sort of script on. And so what I have done is I have added inside of this .github workflows folder, I've added this script file, which says anytime that I push to this commit, go and run this command. And so this is running on GitHub servers. And what this effectively does is it just makes sure that there's no trailing white space in the files. And you can see, so I now have this checkbox here because that means that none of my files have trailing white space. So the whole idea with GitHub Actions is you get a little, or the continuous integration, is you get a little checkbox that says yes, your code is good. But if I made a mistake, maybe if I posted a file with trailing white space, that would mean now my code is bad, and I would get an email sent directly to me. And this is important because if you're managing a large-scale final project for this class, you need to make sure that if you ever push code that fails a bunch of tests, that the person who pushed that code gets an email and says, hey, the code you just pushed is bad, and you need to fix it ASAP because you've just poisoned the branch. So anyways, GitHub Actions, continuous integration. We'll talk more about it on Friday, but I just wanted to give a short intro so that you understand better what's happening with homework 4. So cool, okay. Thank you, everyone. Remember, if you are a Monday section person, then please try to get together with your group so that you can all get a head start on the final project. Good. Okay. I'll see you on Friday.